This is from page 88 in the textbook, and it's just like those problems on in my math lab. So let's walk through some of these. So what I'm seeing is looks like the y equals x cubed function. Looks like the cubic function, and it looks like it's been shifted. So I mean, here's this blue graph I made. Is the it's supposed to be y equals x cubed, right? I don't think I have the curvature quite right here, but you get the idea. So a couple of key points when I'm looking at a cubic graph, I'm seeing that point that goes to the origin, right? And then I'm looking up at this other graph up here, and the one they want me to find the equation of, and that's where I'm seeing this point's been moved up there. So what I'm seeing is I'm seeing a shift right of 1 and a shift up of 2. So I know I can write this as x right 1 cubed and then up 2. And if it were, now I got to look for some compression of some sort, of either horizontal or has it been stretched or what. It almost looks like it's been stretched now that I'm saying that word. So there's a couple of ways to tackle this. I know there's some kind of, it's either, I could think of this, I'll tend to look at this as a vertical stretch or stretch or compression, just because it's easier than being in the inside. It's your choice. It really doesn't matter. This is just how I prefer to do it. So I know that's my equation at this point. Now I got to find this stretch factor, right? So that stretch factor. So I'm looking at, I see this graph here, it passes through that point 3,3. So why don't we substitute that in for x and y and solve this for a? So what's that? 3 times, let's see, that's 2. 2 cubed is 8. If I subtract 2 and divide by 8, I get 1/8 for a. So that's what I'm thinking. This is, won't let me erase it, will it? All right, so I'm thinking what I've got is 1/8. I'm write it in a different ink. I'll try that. It's a little sloppy, but so 1/8 times x minus 1. Now what I did is, if I can pull this up, I went out to that excuse me Desmo.com website, and I used the graphing calculator. I typed in that equation I created, and it's looking exactly right. It goes through the 0.33. It has that shift there, and I know I am right. Okay, so that's how you deal with that. That's my approach for that one. So this is from the same page. I'm seeing an absolute value graph. I'm seeing, instead of absolute, when I have an absolute value function, this plain old normal absolute value function opens like this, vertex at 0, 0, and it rises up 1 over 1, up 1 over 1, same deal to the left. Okay, so what I'm seeing is this vertex has been moved to left 1, up 3. So absolute value of x plus 1, because it's minus whatever the left-right shift is, then up 3. And there's probably some kind of stretch factor here. We can, just so with absolute value graphs, here's this little shortcut we can take. I'm seeing a slope of down 2 over 1. So that's telling me that slope is probably going to be -2. For that a term, it'll probably be -2. But I'm going to check it because I make mistakes. So I know I'm seeing a nice point. This goes through the point -3, -1. So let's pretend that a is still there. So -1 equals some factor times -3 plus 1 plus 3. So I'm going to subtract the 3. And so I'm getting -4, not -3. And -3 plus 1 is -2. Absolute value of that is 2. And we divide by 2, and we do get a +2. So we do get that -2 for an a factor, for the slope, depending on how you think of it. Okay. So here I'm seeing a quadratic. I'm seeing the vertex, instead of being at that plain old standard position there, I'm seeing it's been shifted right 1 down 2. So x minus 1 to get it shifting right. Then there's probably some stretch factor going on. Okay, so it goes through the point, let's see, it goes through this point, it has that 0, right? 3, 0, so let's try that. So what's that? That's 2 squared is 4. So 2 equals 4a. So a must be 1/2. So this should be 1/2, and that is that equation. So I hope this helps you solve the rest of those problems on my Open Math.